Magnetic force, a suspended circuit. The figure is a 3D representation of a circuit. An unknown resistor R is on side W, that's right there, which is closest to us and runs vertically. Also on side W is a 24-volt battery, which is not yet shown because it will be up to us to decide on its orientation, whether it's trying to push charge up toward the top of the page or down toward the bottom. Side Y is parallel to side W, but is further away from us. Sides X and Z run into and out of the page, with side X passing through the magnetic field that runs left and right between the poles of the magnet. The circuit's mass is 0.5 kilograms. Earth's gravity acts toward the bottom of the page as shown. Assume that the magnetic field is a uniform 2.5 teslas over the entire length of side X. So we're assuming that all of side X has a uniform magnetic field of 2.5 teslas. We can see that the length of that side is 0.25 meters. The mass of the circuit is half a kilogram. So there's our magnetic field. You can see I put it into the drawing. We have a 24-volt battery, and there's the mass. That's as much information as we need. What's the circuit's weight? Well, weight is m times g. And since g is 10, the mass is 0.5, that's going to be 5 newtons. If you want to say directed downward, you can say that. To suspend the circuit in midair, there must be a magnetic force in which direction? On side X. Well, it better be up. If we want this circuit to be suspended, it's got to have a magnetic force that cancels gravity. How will the magnitudes of those two forces compare? They're going to be equal. So far, so good. Determine the direction that current must be flowing through the resistor in order to achieve our part B answer. We said that there had to be a magnetic force that is directed upward. Let's use our pat-pat right-hand rule to figure out which way current has to be flowing through side X. And once we know that, then we can figure out which way the current is going through this resistor. Let's get our right hand out here. And we want the force to be directed upward. And we know that the magnetic field goes from North Pole to South Pole on the outside of a magnet. On the inside of a magnet, it goes South Pole to North Pole, but we're outside the magnet. So from North Pole to South Pole, we want the pat-pat to be up. We want our fingers pointing in the direction of the magnetic field. So look at my thumb, it points into the page, which means if it points into the page there, it must be going this way through that resistor. The current has to be going up. Indicate this current by drawing into the figure an eye with an appropriately directed arrow next to the resistor. Boom, we just did that. Draw into the figure the schematic symbol for a battery having the correct orientation. Well, obviously then the positive terminal is up there and the negative terminal is going to be down there. So now we know the orientation of the battery. Determine the magnitude of the current that must flow through the circuit. Well, let's see. A magnetic force, whenever we have a current that is going through a wire of length L, and the length L that is in a magnetic field has that magnitude. Again, everything is perpendicular here, so we don't have to worry about the fact that in the vector equation, L and B have a cross product. What's the magnitude of this magnetic force? Well, we said that that had to be numerically equal to m times g. And we decided that m times g was 5 newtons, and the magnetic field has a magnitude of 2.5 teslas. The length of that wire is given right here, 0.25 meters. Again, we are assuming that all of that is going through the magnetic field. So I think the only thing we don't have here is the current. So I think we're going to take 5 divided by 2.5, so that gives us 2. And then we're, in essence, going to multiply by 4, the reciprocal of 0.25. So I think we're going to end up with a current needed to be 8 amps. And what would the resistance have to be to have 8 amps of current going through here? The voltage is 24 volts. There's only one resistor, and if the current is 8 amps, Ohm's law, the current is 8, the voltage is 24. So I think this has to be a 3 ohm resistor.